Okay, thank you. Good morning. I'd like to say good morning, but it's actually almost lunch, so. Okay, I'm getting some feedback. Okay, let's try here. Okay, we're good. We're good. Okay, so today we're going to talk about elections. It's like we started off with quantum computing, and now we're going to go old school here. So, um, yeah, this was me writing in the newspaper. Probably like the first and last time I'll write in the newspaper. This was in 2017, and I've been complaining on Twitter, or actually asking lots of questions about election security in Norway. And then someone on Twitter who was a journalist said, put your money where your mouth is and write in the newspaper, and maybe they'll actually answer you. So I did, and they did. It wasn't a very good answer, though, so I kept on asking questions. Yeah, I ended up making a lot of fuss. This was sort of the beginning, but after a while, I ended up reading more and more documentation about election systems in Norway, and realizing that the state of affairs wasn't all that great. So yeah, ended up on TV like 3 times in one day. I've been on the radio. I just want to say that was. I mean, it's like being on TV. It's like, yeah, but I've been on the radio. Like, actually, yeah. Anyway, so I made a lot of fuss. I really actually continued making more fuss. And that's basically been my job in this domain. In another talk, I referred to it as being annoying as a service. So, yeah, that's me. Anyway, the thing is, there are some things that have changed, and especially in 2019, we saw some changes that are very interesting, I think, for the future of election security in Norway. One of the things that we had a temporary regulation that was introduced in 2017 after I made a lot of fuss that said this, that all of the ballots in Norway had to be counted manually at least once. But the regulation, which was for the 2017 parliamentary election, was only valid for that one election. So a part of me being annoying after that was trying to make this a permanent regulation, which happened this year. So that is really good. The reason why it's good is because we don't really have any audit of any machine counts in Norway. And we still don't. They made some adjustments for the last year's election, where they had what they called a stikkprøvekontroll, which was basically the software checking itself. So yeah, so you didn't really get any further. We also had our first election with this in place, which was like a first real election with this in place. But this means that currently we've done 2 elections like this, both parliamentary election and also local government election, with 1 manual count, which also shows that this scales. It's been proven in practice twice now in national elections. So another important thing that happened was that January 1st, 2019, we got the new National Security Act. And this one it has large ramifications on many things, but one of the really important things here is that it made the democratic process of Norway to be a matter of national security. And this actually meant that until now, the election directorate in Norway had to invite other parts of national security, like NSM, which is the Norwegian NSA type of thing. They had to invite them to come and look at their software, whereas now it is actually a part of their job to make sure that elections in Norway are correct. So that's also very interesting, and so far we don't know much about what effect this will have, but I believe it will be very interesting going forward. And yeah. But the thing is, one of the things I want to talk about is that in 2017, when I started talking about this, people were starting to get worried about election security. And that was specifically because of the 2016 elections in the US, where this became a topic. But the thing is, and I think that is super important to say, that elections did not become less secure in 2016 or 2017 or 2015. They were equally insecure for many years prior to that. There wasn't actually anything specifically that happened. Yes, maybe somebody hacked something, but it didn't make anything less secure. They were already insecure. But the thing that changed, and the reason why it became so important, was that suddenly it became a part of people's threat model. They started thinking that this might actually happen. Up until then, I talked about election security with government in Norway when back in 2005, and nobody cared. It was absolutely impossible to get anybody to care about these things. What happened in 2017 is that people suddenly started listening. And that is true all over the world. Like, people who worked on election security for the last 20 years have had the exact same problem. These are not new problems. These are old problems. It's just that nobody wanted to listen to them. But let's have an election. So we have the election for the Norwegian presidency. We don't have one, so it's about time. So we have the turtle versus the hare. Okay, so you are going to vote. So everyone in favor of the turtle, please raise your hand. Excellent. Okay, everyone in favor of the hare. Okay, what is really funny is that the distribution is pretty good. So these are the results. So the hare definitely won with 63.1%, or the turtle I meant, and the hare lost with 36.9%, which is a famous number in election history in Norway, but it doesn't really matter. But the point here is that nobody actually believed that that I counted you now and that I updated these numbers standing over here, right? You look at this and you know it's fake. But what if I had put a bunch of cameras here with image recognition software that would scan the audience and pick out the hands, and I would show like a live view of this, so I could pick out the hands in the audience, and you would have some kind of dynamic thing showing like, oh, counting up and down and blah, 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 and then stabilizing, and then it's like, but ta-da, these are the results. Chances are you probably believe it was real, or at least plausible. And the thing is, you wouldn't be wrong, because I can actually make that. That is something I can do. The thing is, today, how do you know that the election results that you get are real, that they are the true result of the election? Because who can you trust when it comes to elections? And who are the people who are feeding you that data? So this will be an introduction to election security. So hopefully by the time you're done with this talk, you will have enough to understand the field and enough to dig further into it, but also just enough to realize the problems in this area. So I'm a trainer, consultant. I'm professionally a C++ programmer working in application security. For my own company, Turtlesec, currently. I've worked at Opera Software and Vivaldi making browsers, at Cisco Systems making embedded telepresence systems. I also managed to be a Java consultant for a couple of years too. Master's in computer science, and I'm also on the board for the Oslo B-Sides, by the way, which is on May 13th. The ticket prices are going to be 486 Norwegian kroners, really cheap. The call for papers open, please submit. It will be awesome. This will be our second year, so yeah. Anyway, this is Matt Blaze. I'm going to read the tweet for you. So this is from 2018, but he has plenty of tweets that basically say the same thing. I've said this before, I'll say it again. I've been working in security and large-scale systems for over 25 years. Civil voting is by far the hardest and most complex problem I've ever encountered. Now, Matt Blaze is a professor. He's been working with election security for 20 years. But he's also working in many other things with regards to information security. And he's saying that civil voting is by far the hardest, most complex problem he's ever encountered. Okay, so this is interesting. Because complex, it doesn't seem like a very complex problem. I mean, this should be calculation, basically. You have maybe pieces of paper or numbers, you're supposed to add them up. Yeah, maybe the math is kind of iffy, but it shouldn't be hard, right? This doesn't sound like a complex problem. And then looking at the Norwegian election system specifically, is the Norwegian election system complex, like inherently complex in some way? And no, it's not. There's no inherent complexity in election systems when it comes to what the task at hand. The task at hand is a bunch of people have to cast their votes, and then you have to count them, and then you have to say who won. I mean, this is not complicated. So this is from a thesis, a master's thesis from 2005. So I'll read the quote. The testing is performed using a prototype implementation in Java, though the implementation does not take into consideration security and anonymity concerns. It is a full implementation of the electoral system. This is from the thesis was called Evaluating the Suitability of EML 4.0 for the Norwegian Electoral System, a Prototype Approach. EML is an election markup language. It's a XML schema definition of messages passed between different parts of an electoral system. This was my thesis in 2005. I made this, and the purpose of making this was basically to figure out, read all of the Norwegian election regulations and laws, try to figure out what are the responsibilities of each part of the system, what are they allowed to store of information, what are they allowed to transfer, and then make an implementation of each system. And then this is a distributed system, like 7 to 9 different systems talking together, different. I even made internet voting, so you could vote on the internet. The client was command line based. It was fabulous. But what is important to understand is that security and anonymity concerns. That is, though the implementation does not take into consideration security and anonymity concerns, it is a full implementation of the electoral system. I made this in a few weeks. There's no inherent complexity in voting. The inherent complexity in elections comes from security and anonymity concerns. And what are these, right? So, and it is complicated. It is complicated. And that's why we have to go through it, because this is where I always get stuck on Twitter when we start talking about this. People are wondering, like, how can this be so hard? I do my banking online. I trust my online bank with all of my money. Why can't I trust computers with my voting? So first of all, we have to start defining the basics. Like, what are we actually trying to protect here? And the worst case scenario of a rigged election, and a rigged here is a successfully rigged election, right? The worst case is that we accepted the manipulated result. If we have an accepted manipulated election result, we have hacked a nation, right? We've basically replaced the true elected government. But to understand what is an election result, because that is also one of the things that you saw with the turtle versus the hare, is that was a majority win. The election result is the distribution of the mandate. So it's basically for the turtle and the hare is who wins, the turtle or the hare. That is the election result, not the numbers, right? So that gives us a very interesting principle in election security, is that the election doesn't have to be flawless. It allows for errors. It allows for a lot of errors in the whole system, as long as the election result is correct. So as long as the result, the actual winners of the election are the legitimate winners of the election, you have a lot of leeway when it comes to flaws in the system. And when we saw here, the turtle won here by 13%. Even if I manipulated this in a quite large way in election security, let's say that I managed to move the election by 2%, so which is huge in election security, the turtle would still win. I could move the election with 10% and the turtle will still win. And that gives you an idea on how much flexibility there is in election security. Now, of course, you might end up in a very close election, and then the question is, how do you handle really close elections? In Norway, we don't really have any legislation around close elections. In many states in the US, they have rules that say that if you have a result that is this and this close, you have to fall back to a full manual recount. We have no such rules in Norway. Okay, so we have like, this is our worst case scenario, but what is our threat model here? What are we looking at? What are we afraid of as actual actions within the system? So we're afraid that people will add ballots. We're afraid that people will remove ballots. Often both of these together, right? Like you take out 100 of these and you add 100 of those. You're afraid that people might change ballots in some way. Or that they will just report the wrong counts. I mean, you can have like a full count of everything and everything's correct, and when you actually report the counts in, you just lie. But at its most extreme, what we're trying to do is to prevent a coup. And that is the fundamental thing. People think sometimes that election system is just another system in the government, just one out of like 1,000 different systems in the government. But this system underpins the entire democracy. If this system breaks, the whole country breaks. You can have a transition into a fascist government with a flaw in the system. We're trying to keep a democracy that is real. And when I say real, it is because there are plenty of countries in the world that have fake democracies. Many, like Saddam Hussein had elections. He had elections where he won by 99.999%. It was fabulous. Then people said, like, how do you know? And he was like, no, we had a census 2 years ago and everybody voted for me. And they were like, so in those 2 years, nobody died? Doesn't matter. And why do people do this? I don't know. Like, it's politics. I don't know. But people keep on faking democracy. It's a thing. You see it a lot in Eastern Europe and former Soviet Republic countries. You have a lot of fake democracies. Okay, so now we have an idea of what are we afraid of, what are we trying to protect, but who are our threat actors? Like, who might want to harm these things? Who might want to manipulate an election? And this is what will make our problem the most difficult. This is what is going to make election security the most difficult. The most likely threat actor, historically, that means throughout the time of elections, like forever. But it also means in near history. If you only look at the last century, this is true. So the most likely threat actor, historically, internationally, all over the world, this year, or well, not this year's not very long. Last year, I'm talking globally today. The most likely threat actor in an election is the sitting government. That is the most likely threat actor. That makes this really hard because, well, we'll get to that. Okay, but we have other ones as well. You have foreign governments. Foreign governments might want to tamper in your election to put in some sort of government that they feel is more friendly to their interests. One of the governments that have done the most in this area is the United States. The United States has tampered in many other countries' elections, which kind of makes it a little bit awkward, this whole period. But you also have private companies. You have lots of private companies in Central America that have been tampering in elections to serve their market in some way. And this is also the reason why you have the term a banana republic. It is a country that is being manipulated by a large corporation. Then you have things like terrorists, activists, and lone wolves. And the funny thing is, people think that these groups are the ones you have to be afraid of, but they are insignificant when it comes to threat actors here. So, back to our main threat actor, right? The most likely threat actor in an election is the sitting government. That means not even the opposition. The people who are currently in power are the most likely people to manipulate an election. These are, unfortunately, also the same people who are running the election. Okay? In Norway, the Directorate of Elections is under the Ministry of Local Government. They work for them. The head of the director of the Ministry of Elections is appointed by the Ministry of Local Authority in Norway. He knows who he works for. Another thing that is very surprising to many people is that you have two acceptable outcomes when it comes to election security. The first one is, of course, a correct election. In this case, a correct election result, right? So the right distribution of mandates. So if everybody gets what they were supposed to get, then we're all happy. The other interesting part is that you have prevented a rigged election. This is an acceptable result in election security, at least theoretically. Theoretically, if you are able to say that, yes, somebody tried to rig the election, but we detected it, we are going to throw out this election result, and then we're going to do something. Unfortunately, this something is a little bit difficult, because sometimes it might be very hard to correct the results. Especially if having an election is super expensive. And in many, many countries, having an election is ridiculously expensive. Trying to do a new election might not be feasible. And so that is the state in the US right now. Many people in election security in the US today don't believe that doing a new election is feasible. And so then you have to say, what can we do with the results as we have it? Now, one of the things that you could say is that, yeah, we know that somebody meddled in this part of the country, or in this city, or in this neighborhood we have meddling, or in this specific system. Okay, so fine. So then you can say, and it happens, that we'll throw that result out. That partial result will throw it out. But of course, as most of you probably have already thought about, this is a great way to hack the election as well. You don't actually have to hack the results. You just have to hack into a bunch of places where they don't vote your way. And then you can get all of their votes thrown out. So, yeah. It's a problem. So when it comes down, well, we talked about the threat actors. We talked about the things we're trying to protect. But what comes up a lot is the concept of anonymity. And what does that mean? Both to how hard the problem is, but also to what we're trying to achieve. What does really a secret ballot give to a democracy? True democracy requires the freedom of all of us to vote our conscience. That is the whole premise of a democracy. It is that even though you might not feel comfortable saying what you vote to your boss, you will still go and vote your conscience. You will still do what you think is right. And you have to feel safe to do that. You have to feel safe that you can do that and not suffer any repercussions. So we have some goals. We want to prevent coercion. We don't want your family members to be able to make you vote a certain way. We don't want your boss to be able to make you vote a certain way. We don't want your government to be able to make you vote a certain way. So you have to protect the singular, the person that is voting, for possible repercussions from voting their conscience. You also want to prevent vote selling. Because the thing is, if you can prove that you voted a certain way, like the right way, then now you can sell your vote because you can prove that you did it right. Now, I said this to election observers for the 2017 parliamentary election, and they were all from Eastern Europe. And I said, yeah, but it's hard. We want to prevent vote selling so people can't prove what they voted and things like that. And they were like, oh, yeah. And they all put their hands up because we had a Russian translator, so we had to go through. And it was like a long sequence of things. And then they said, yeah, but they have ways around this. And I was like, yeah, what? And they were like, yeah, well, you take a picture of the ballot with your iPhone, like in the booth. And I'm like, okay, but you take a picture, but you can still change it out, right? Because in Norway, you go into a booth, you pick who you want to vote for. Sometimes you've had it, so you put it in an envelope, but mostly you just fold it and you carry it over, and nobody can see what you voted, and you put it into a ballot box. And so I can just take a picture of something and then take another one and put that one in the ballot box. And they were like, oh, we got ways around that too. And then they were like, okay, so you need a man on the inside. And then what you do is you pay, you say you'll pay 100 people to vote for a certain way. The person on the inside will check that the results come in. And if there are only 99 votes that go your way, nobody gets paid. And I was like, good system. And they were all like, no, bad system. But you're putting in an element of peer pressure now. So now people are watching each other, because if one person doesn't do what they're supposed to do, then there's ramifications for everyone, right? And in a democracy that you know is already rigged, people won't necessarily find value in their vote, because it's like it doesn't matter anyway. The whole thing is rigged. So I might as well get paid. Yeah, so prevent vote selling. Prevent persecution. We don't want you to be persecuted for voting a certain way. And people are like, yeah, but I'm not worried. Norwegian government is never going to put me in jail. But the thing is, yeah, they might not put you in jail now. But what about in the future? If the government has a record of how you have voted over time, that record is handed off to all new governments. And then people are like, yeah, but I'm not worried about, new governments. And it's like, yeah, I'm sure like 3 or 4 years ago, Americans would have said the same thing. Not so much anymore. Do you really want the government to have this information? And then I don't say the government right now, but what in 10 years? What if Norway suddenly gets a fascist government? And they have a list of everyone who's voted for the Communist Party for the last 20 years. So we're gonna have to go there, because I always have to go there. The answer is not the blockchain. It's funny how rarely the answer is actually the blockchain. But no, the answer is not the blockchain, and I can't get away from it. So let's talk a little bit about why. Because people keep bringing it up. First of all, to prevent persecution, right? We don't want, now or in the future, anyone to persecute you for how you voted. You don't want to connect a vote to a person. You don't want any way to connect this specific vote to this specific person. Okay, so that's a problem. To prevent coercion and vote selling, both of them, sort of similar. One will punish you for voting the wrong way. The other one will reward you for voting the right way. You don't want a person to be able to prove what they voted. And also, what put that vote on the blockchain? Like, can you trust that? Who's in charge of that? And what about chain of custody from the time you cast your ballot until it came on the blockchain? If you can't check that it is your vote, then how can you trust what's on the blockchain? So moving on. So let's talk about statistics. And this is how to evaluate some of the risks that we have, because this is something that comes up a lot. So man versus machine, manual versus machine counting of ballots. And people say, oh, you hate computers? Now, I've been programming for 20 years, okay? So no, I don't hate computers. But manual elections are really, really hard to beat. They're very, very difficult to do better because they have lots of security elements that are baked in. And these are things that you don't even think about when you consider elections. You have the concept of, for example, a ballot box. And you think, yeah, well, we need a place to store the ballots. It's a useful thing to put the ballots in a box. But actually, the ballot box has an election security purpose. If you go and put a ballot in a ballot box, and then 1,000 more people put a ballot in that ballot box, even if somebody gets a hold of that ballot box, it's very hard to figure out who voted what. They're all mixed up in there. It is a part of the anonymity chain. It's part of it's the first step to break the connection to you. It is that it has already been mixed up in a ballot box, and you can't open the ballot box before a certain period has gone by. So the thing is, this thing is also a part of your protection. So yeah, manual elections have lots of really, really tiny details that make election security better. But people are like, isn't manual counting slow? And I found this specifically interesting this fall because several places in Norway, they had the manual results ready, but they were waiting for the machine count. So the reason why it's not slow is it seems surprising, but when you think about it, it makes sense. It is massively distributed. And this makes also a difference in many other ways because you count all over the country. You have thousands of people counting locally the ballots that they have. And because it is massively distributed, you can do it all at the same time. But you also have tons of people involved in the process. And this is also a part of election security when it comes to manual elections, because to be able to move an election, now you have to be in so many places, which suddenly mean you need so many people. And this becomes a massive conspiracy. This is not something that one person can do alone. This is something that requires hundreds, maybe thousands of people. And it becomes really hard to hide. So chances are you're going to get caught. Somebody's going to get caught. And it's super risky as well because you have to actually be there in person, in the location with people around you who don't trust you. And if something happens, they can just lock the door and not let you out and call the police. It's very super risky. So yeah, so it's massively distributed, but also the fact that you don't need really any equipment means that you can do it anywhere. One of the things that you've seen, for example, in the US is that they're using computers and machines to do both voting and counting. But the thing is then they're centralizing the voting locations to maybe one place for a very big neighborhood or a city. And suddenly it becomes very hard for people to vote because they have to go to a place and they might not have a car, so you might have to take buses. And the whole process of going there becomes hard. And people who are already poor find it hard to vote. So having a manual count means you can have a voting location in the local church, in the local community center. You can have it at the local school. Suddenly, the voting locations can be anywhere because you don't need any special equipment. So is it error prone? Yes. The answer is yes. Any one of us know that counting is error prone. Manual counting, we count all the time. We know exactly that it is how error prone it is. But it is also no. And that is the interesting part, right? I said that elections don't have to be flawless. And so what does that mean in the case of manual error counts? That is something we're going to look at now. So let's... I'm going to show you the risk model for manual versus machine counting of ballots. Now, these are paper ballots, right? So it's basically, do you have, in Norway, a Windows machine connected to the internet with a desktop scanner connected by USB counting your ballots, or do you have a human? That's what we're talking about. Okay. So to evaluate the severity, we need to figure out how can we say how bad something is. So these are our major criteria. Can it affect the election result? Can this make somebody else who shouldn't have been voted in be voted in? Can it go undetected? Okay, so the combination of these two are like worst case scenario. This means that we have no control at all. Can it discredit the election result? Can people maybe start to wonder if the result is correct or not? Now, in Norway, this is not a big deal. I've done nothing but for 2 years. We're still good. But in some countries, this can be a massive deal. If people start believing that the elections have been manipulated, if you already have a tense political situation in the country, things like this can result in civil war. So it's not. So in many countries, this is a big deal. Can it create more work? And the funny thing is, this is what local governments care about. It's like because they only care about how much work it is. They probably care about these things, but they only talk about number 4. But also we have to think, okay, so how historically likely is it? Even like, does it happen often? Have we had any case of this ever happening? I mean, that is also an issue. And of course, this can change. Like, even though it has never been an issue before, can it suddenly become an issue? Like, I saw someone saying that one of the primary causes of Russia meddling in the US elections is to point at these so-called functioning democracies and say, look, they don't even have it together. It's clearly that, this is messed up over here as well. And currently, of course, the Americans are pointing at Norway going, look, there's like a functioning social democracy. Now, that might actually change the threat model for Norway, right? Because hacking Norwegian elections, showing that they are also vulnerable, could be a way for Russia to say, this country, I mean, this is your goal. So who knows? So we're going to put it onto this chart. So the likelihood is the y-axis, the severity is the x-axis, and this is, I'm not going to put any values to this. We're just going to place them relative to each other. So what I'm going to do is I'm going to look at the likelihood of manual versus machine, and then I have innocent versus premeditated. So innocent, when it comes to a machine, would be a bug, right? It would just be nobody intended for this to be wrong, but there was an error, right? For innocent, innocent for manual counting, it would be just a counting error. Like, nobody meant for it to go wrong, you just counted wrong. Now, it might be interesting how the likelihood is super high for innocent manual errors. But it's not really, because we all kind of know that you're going to make mistakes no matter how you do it, right? And premeditated is low, and it's basically low because it's a really high chance that you're going to get caught. So doing this at any scale is not going to happen because you need so many people to be able to move the election result. So it's a very high likelihood that you will get caught. When it comes to machine, it might be a little bit surprising. That is low to medium. And that is because currently we have had bugs in the systems that count ballots in Norway. For every single election, there have been bugs. Every single election for the past 20 years, there have been bugs that have been discovered on election day or after election day. Before and after the election result has been accepted, there have been bugs. So this is, like, the chances of there being bugs, huge. Okay? The problem and the reason why it's low is that it's a big chance that you'll find them, because bugs have a tendency to be reproducible, right? So if something, so an example of a bug that was found was a guy who got a lot of person votes, like extra votes. And people are like, who is this guy? I've never heard of this guy. He just got suddenly 123 person votes. So they went through all of the ballots again, and it turns out he hadn't gotten any. And what happened is that you have to write in the name manually. And if you had any kind of name that had like a J or a G that kind of went down to the next line, then the software would read that as something was written on the next line. And when it couldn't detect what it was, it just picked the first person. So yeah, but it has this tendency of being very obvious because it tends to be a lot, right? But then you have things that are rare but might change things. So you have this, I think, was in Bergen on the ballot for Bergen for the Labour Party. You had a guy who came in after the election, right? And he says there must be something wrong with the results. And they were like, why? And he was like, no, because I'm on this ballot. I'm on the second column in this ballot. And it says here, I got no person votes. But I know that I got at least one because I gave one to myself. Now, then they went through all of the ballots for the Labour Party. It turns out nobody in the second column got any person votes because there was a font change. I think it went from bold to not bold or something, which shifted the second column just a little bit, enough that the software couldn't read any of the person votes in the second column. So anyway, so the point here is that we do discover bugs all the time. And sometimes it will be easy to find, sometimes it will be hard. But don't think that just because we found some does not mean we didn't miss some. We probably did. So when it comes to severity, like this is how bad is it going to be for democracy if we have these errors? And the surprising part here is probably that innocent manual errors have a really high likelihood, but they have a very low severity. And the reason for that is that innocent manual errors, they distribute proportionally on parties. So let's say that you make 2 errors per 1,000 ballots. Then a party that has 50,000 ballots will have more errors. A party that has few will have less. And because it distributes statistically proportionally on the different parties, it has very little effect. Now, the problem is with very small parties, of course, you can be unfortunate and get a little bit too many, and it can harm you a lot, just a few errors. But for big parties, this has basically no effect at all. Yeah. When it comes to premeditated counting errors, so this means people who are deliberately trying to rig an election by doing something with the ballots manually, like being at the location I've already talked about it's probably going to be detected. But one of the things that is bad when it comes to elections is that the moment people have touched the ballots, the moment they have made changes physically with the ballots, you can no longer trust the ballots. And that means it's really hard to recover from compromised ballots. Like if you know that people have been in there and messing with these ballot boxes, can you trust any of the ballots anymore? And that's a good thing about premeditated machine counts. This is your typical, like somebody hacked the computers that counted it. Because if you find out, the ballots are still fine. These people are doing this remotely. You still have the paper. You can always count again. So some of these things make it a little bit more difficult. But anyway, combining these two, and you find out that, okay, so innocent errors for manual counts has a really high likelihood but very low severity. When it comes to machine counts, they're different. And this is one of the things that people need to understand to be able to discuss this, is that these are not symmetrical. If you take them all up, you'll see that machine counts are down here. This one is really bad, because if you are able to hack in and change results, chances are you won't get caught. Because the thing is here with this is no machine count audit. And that is the case for almost all machine counts in the world today. There is no audit of the result. And that is true for Norway as well. Even though we currently have a manual and a machine count, we have no real audit of the election result in Norway. You have the opportunity to compare the manual with the machine count. And what we saw this fall is that nobody cares if they're not the same. What they did was they took the ballots and then fed them through the machines again. And if they got the same result, which they often did not, which was very interesting, they just did it again. And they did it again until two of the counts showed the same number, and then that's what the final result was. So it was very interesting, and me and a couple of other people have been submitting complaints all over Norway to try to figure this out, to make them at least explain the discrepancy between the manual and the machine count, because all they did was write, there must have been an error in the manual count. That's it. And the reason why, of course, is because they had to write this on a Word document, and there was and it was a PDF, I think, and there was only so many characters you could put into the field, so it was very hard to write anything sensible as the reason why. Anyway, this was done really well in Oslo, which really pissed me off because this was the only place I could actually complain officially in Norway. But, for parliamentary elections, you can complain all over the country. It's just local elections, you can only complain locally. Anyway, but what if we actually then introduce some mitigations here? So the idea is, okay, should we just go back to manual? Totally manual elections. We'll just people count and people vote on ballots, and then we don't have the computers in this at all. People are like, just take out all of the computers. And the goal in election security is actually a little bit different. The goal is something that is called software independence. And this is from a paper by Ron Rivest, who is the R in RSA, and John P. Wack at NIST. And this is the quote from the paper. A voting system is software independent if an undetected change or error in its software cannot cause an undetectable change or error in an election outcome. So the name of the paper was On the Notion of Software Independence in Voting Systems. Now this is super important. It says that if you have an undetected change or error, so this can be a bug as well, does not cause an undetectable change or error in the outcome, in the election result. And this is super abstract. Like, this does not give you a solution. It gives you a criteria, but it doesn't actually give you a solution. But that has become the goal. Like, how can we achieve this? And that is through auditability. Can you make an election so that it can be audited? Can you make an election so that it can be audited by people not in the government, right? Our most likely threat actor cannot be your auditor. You have to have somebody outside of the system doing the auditing. And most preferably, it should be normal people. It should not be any party in the election. It should be anybody. You should be able to just grab a random group on the street and go in, okay, you are now our auditors. We need you to tell us if this result is correct or likely to be correct. And so this is another quote from the same paper. Verify the election results, not the voting system. The thing is, people say, like, yeah, but you can make the system open source and then people can verify that it is correct. And yes, like, yeah, you can do all of that, and you should do all of that. But on election day, do you know what software is running? Do you know if it is the same code that you looked at? They had a voting system in Switzerland where they published it open source, said anybody can come look at it. They found tons of problems, okay? But that's a whole other issue. But one of the things that they had was they had a configuration file that said how long are the keys, how long are all of the parameterization of the cryptography was in a config file. The config file that was delivered with the system was the debug config. And they were like, yeah, don't worry. On election day, we'll have a totally different configuration file. Anyway, okay. But what is really a manual election, right? You have paper ballots, and you need paper ballots. I'm not saying paper ballots will solve everything, but you need at least paper ballots. And then some sort of manual count. Now, in this case, you don't have to abolish all computers. All you have to make sure is that any part of the system that isn't already auditable needs to be manual. And the thing is that is like imagine that you are in a voting location, you've done all of the counting, been done manually, you have a piece of paper in front of you, you are going to send it to the central something. You can do that through a computer, call somebody on the phone, I don't care. It's going to be transmitted. So you have the list and the numbers and you've sent it. Later on that evening, you're sitting on your couch and you're watching TV and you're getting, yeah, the results from polling location X are blah. You have your piece of paper. You can look on the TV. You can check that the numbers on the TV match what you sent. That is auditable by a person, a human, right? So you can keep computers for anything that is auditable. So auditable elections. You still have paper ballots, but you have a manual audit. Now, this is the goal in the US right now. This is what they're trying to do. In the US, they find that the manual count is absolutely not doable. And the reason for that is the complexity of the ballots in the states are enormous. Like voting in the US is like doing a multiple choice test. It is massive, and you have to you have to go all over it. It is very hard to count manually. And it takes a really long time because for all of the ballots, you have to go through what did they vote in all of the elections. And they have maybe 70 elections on one ballot. Okay? They are voting for everything from the school janitor to the president of the United States on the same ballot. Okay? So this is totally not doable. But in Norway, it's super easy. We're basically counting paper. So counting ballots in Norway is super easy. So what happens to our risk diagram the moment we introduce audits for our machine counts? And it is interesting. An audit will reveal bugs, like any kind of we had a bug, but we were able to see it. So now we can maybe do a recount, fix the bug. What happened, what you saw, both with the guy that got all of the person votes and the guy on the second column on the Labour Party ballot, they just fixed it and counted all the ballots again, right? So it will reveal bugs, but it will also reveal manipulations. Now, I like the word manipulated because I had a really hard time talking on TV. If I say the word hacked, then everybody was like, oh my God, tinfoil hat. So if you say manipulation instead of hack, it really helps. Just pro tip, everybody's like, manipulate, yes, I can see that happening. And then you say hack and people are like, so manipulations are really nice. Anyway, but what you see is that because you can reveal both of these, right? What happens is that the severity changes. It doesn't change the likelihood, although it could. I mean, the thing is, if you have an audit, if everybody knows you have an audit, then doing a manipulation is less likely to lead to a manipulated election result. You know that they're probably going to find out. But it changes the severity. It doesn't really change the likelihood, but it changes the severity because you can recover. You can fix it. And that's the most important thing. So what is an implementation of this? So from 2019 in Norway, we have a manual preliminary count. We can talk about how that came to be some other time, or you can just search for Patricia and elections on Twitter. But anyway, so we have two counts. We have a preliminary and a final in Norway. The results can be compared. Now, can is the operative word here. The goal for the US researchers currently is something they call risk limiting audits. Now, this is, I probably have it here. Yeah, what is it? It's a statistical model for manual ballot sampling. And it's quite simple. Like if we go back to the voting of the turtle and the hare, let's say that we had a result that 90% of you, let's say that we had a secret ballot to make this interesting, right? So 90% of you voted for the hare, let's say. Now, if I can take 10 of you and just do the election with only 10 of you, and all of those 10 voted for the turtle, it's a high likelihood there was something wrong with the total result. Because if 90% of you did vote for the hare and those 10 all voted for the turtle, there's something iffy going on. So what they do is that they gradually increase the amount of ballots that are participating in this statistical model until at the end, if they cannot confirm the result as it was, it will fall back to a full manual recount, because in the end, all ballots will be part of this sampling. Yeah. So there was a thesis that was handed in last year in 2019, which was looking at error detection mechanisms in Norway's election system. The Norwegian electoral system, a study of EVA scanning, implemented error detection mechanism and applicability of risk limiting audits. So if this is something you find interesting, then Vilde Elise Sommer Amundsen handed it in and got an A, so it's a good paper. I was her thesis advisor, so I'm just plugging it here. Anyway, so yes. But what was the problem here in Norway, and why did I make such a fuss? Well, actually, what is the problem? Because we've gotten a certain way, right? We've gotten one manual count. What we used to have, and what was the case for the 2017 parliamentary elections in Norway, was that half, maybe, to 2/3 of all Norwegian ballots were scheduled to be only counted by computers. Only counted by computers running software that nobody had ever seen, running on Windows computers that you could, like the actual description on how to set up the system was you can reuse computers you have already. These were desktop machines, right? You could reuse computers you had already. You downloaded software from Valgdirektoratet. You ran it on these Windows machines. The actual count was done on a Microsoft SQL server, and okay, it's a whole other thing, out of scope for this. But anyway, so now we have a manual and a machine count, but we have no audit. There is no system to compare these two results to each other. They had one part of the report where they had to comment on why there was a difference, and they basically, this fall, said, I don't know, it was different. We counted again with machines. Now, the thing is, what is the value of the manual count if you keep on counting with machine and only accept the machine result? We're falling back to the exact same thing, which means that all over Norway, everywhere that we're using computers at all, there was a machine count with an interesting add-on of having a manual count. So paper ballots are not enough. You have to have an audit. You actually have to have some way to compare, some kind of manual process with the machines. And it has to be able to be performed by regular people. We can't have experts. We can't say that, no, here's our cryptographic expert that has analyzed this system, and now you have to trust that one person not to be corrupt. Now, how much do I have to pay this one person? You know? It's like if I'm an oil company and I know that if I get my government in, then I can open these sections of the Norwegian Sea for oil exploitation. Yeah, that was not a good word there. Sorry. Exploration. Then, you know, that might be billions and billions of dollars for me, right? So I might say that paying this one person 100 million is actually going to be good for my business. So it has to be performed by regular people. You have to be able to have anyone do this. And manually counted elections have a built-in audit. And that is people. People don't trust other people. Like, seriously, we trust computers like crazy, but we don't trust people. Like, if we are sitting next to a person, you are sure he is making more mistakes than you. And you are not sure about his politics, and you're paying specific attention that he's not messing around with your party. The problem is when I try to explain this to people, I say that the moment you put all of your ballots to be counted only by computers, it's just like a group of like 3 people came in, took all of your ballot boxes into a room, locked the door, and told you, we'll get back to you on what the results are. And the moment you say that, people are like, no. And I was like, that's exactly what you're doing. And the people who are going into that room is your biggest threat actor, the local sitting government. Those are the people who are going to be in charge and writing and running the software that is counting the ballots. So we need something else. And manual counted elections can also be rigged. And that's a lot of people from third world countries tell me, like, yeah, we have manual counted elections, but they're totally rigged. And yes, they are totally rigged. And that is true and the feature. Everybody knows. It is super, super hard. Okay. I think we have to wrap it up super quick.
You still have, it's like lunch now, so you can probably finish it.
I hurry. Yes. Okay, but everybody knows they are, and that's the super important part here. So if an election is rigged and nobody knows, then do you still have a democracy? And that is the question. And the thing is, you don't. And that's how easy you flip a government. If you flip one election, the next sitting government are the people who stole the election. They are now in control of the election system. And all you have to protect you after this point is any kind of other mechanism in the system. And that means things like the judicial system, the parliament. You have no election control of this system anymore. Because the people who are running the election are the people who stole it. You've had a coup. Thank you.